Hello, everyone. I'm Jim Garrison. I want to welcome you to this session of Humanity Rising as we begin a 3-day program on cooling climate chaos. We want to delve into this issue as we've done for a number of years now, because climate change is clearly one of the most urgent issues facing humanity. Both short-term and long-term. It's probably the greatest challenge because we have so radically destabilized our global ecology that the ecology now is increasingly being experienced by humans as more and more turbulent and chaotic. Just to give a measure of what this means, in congressional testimony, last month, the senior scientists of the National Oceanic Atmospheric Administration, which monitors climate change for the US government, among other agencies, the scientists said that 20 years ago, we had a $1 billion climate disaster every 2.5 months. Starting about 5 years ago, we're now having a climate disaster that exceeds $1 billion in damage every 2.5 weeks. He projected that as time moves on, we'll very quickly be having a multi-billion-dollar climate disaster every week, 52 weeks a year. And that destroys infrastructure. It destroys people's lives. It destroys the capacity of humans to lead just normal lives. And it's happening not only all over the United States, but all over the world. The great tragedy of our situation, as we all know and we've mentioned, is that our governments are doing essentially nothing. We've had 27 Conference of Parties mandated by the United Nations based on the Intergovernmental Panel on Climate Change, the IPCC reports indicating that we are now in code red. But year by year, our governments in the grip of both the military-industrial complex, as we see in Ukraine, and also the grip of the fossil fuel industry, essentially refuses to take any meaningful action. It's worth noting that the 28th Conference of Parties is going to be in the Emirates this year, and the chairman is the Minister of Oil, who has recently been talking about the importance of integrating oil and fossil fuels into any solution that we want to develop for dealing with climate change. So the global challenges confronting us, both in terms of climate, in terms of war, in terms, as we've seen over the last number of sessions, in terms of artificial intelligence, you start to count up the code red issues and their multiplicity and the way they're impacting one another. Is something that is hard to take in, particularly if you're not very well informed, and even if you are, discerning the connections between the dots is something that requires not only intellectual acuity, but I would say fortitude of emotion and heart. It's like looking at the sun directly with the naked eye. It's hard to sustain the gaze, and yet we must. And so today we're going to return to climate change and focus on some of the solutions that are emerging out of a deeper understanding of the water pathways and the rain and the bionic pump that if properly understood and properly implemented, could ameliorate many of the problems that we have related to climate. So we're going to have a number of experts talking to us over the next 3 days. Before we jump into this very vast and critically important domain, let us pause, as we always do, as we begin our Humanity Rising sessions, in part because of what I just said. It's hard for us, not only intellectually, but with our hearts, with our being, to take in the gravity of the crisis that we're in a world that is literally spinning out of control. How do you keep your center? How do you maintain your equilibrium so that you can just simply cope, much less navigate through the chaos that surrounds us each and every day? We can breathe. One of the most effective ways of maintaining internal coherence and equilibrium and fortitude and health is simply to consciously, coherently breathe. And so the breathing that we do on Humanity Rising is a very specific kind of breathing, known to the ancient mystics for thousands of years, but is now being demonstrated by science to be one of the most effective ways to build up internal coherence. So in a moment, you're going to hear the sound of a bell. When you hear the bell, breathe in for about 5.5 seconds. You'll hear another bell and breathe out for about 5.5 seconds. We're going to take 10 breaths together. If you do this kind of coherence breathing, you take in 5.5 breaths in a minute, and you take in 5.5 liters of air. It's the single most effective way to create coherence through breath known to science. And so we do it on Humanity Rising because we look at some of these tough issues day by day by day, but it's always within the larger frame of how do we empower people through understanding, but how do we empower people through community and through collective conscious coherence. And that's why we breathe. Thank you, everyone. Welcome to Humanity Rising, and let us breathe together as one. Thank you, everyone. It's so good to breathe together and feel the coherence, not only internally, but in our community. We have registered participants from over 130 countries. We broadcast through live streaming partners, sometimes dozens, sometimes hundreds for our various broadcasts. And it's always good to know that humanity rising through collective coherence. Just imagine if the whole world would breathe together in a coherent, conscious way. It would probably enable us to solve most of our problems in a short period of time, because we would realize, as Jalaluddin Rumi said 800 years ago in ancient Persia, that he was neither a Christian, nor a Jew, nor a Muslim, nor a Hindu, nor a Zoroastrian, nor a Buddhist. He said, in the end, beyond the field of right and wrong, all we are breath, breathing beings. We just take that in, that all we are breath, breathing beings. Everything else is derivative. And much of what we make up in our minds separates us. And that's why we're in the global predicament that we're in. And that's why Humanity Rising is here. So thank you, everyone. And now it's my great pleasure to introduce a good friend of mine who I've gotten to know through Humanity Rising, actually, Rob de Laet, who is a successful Dutch entrepreneur who has spent many years in Brazil saving a small little patch of the Amazon and turning it into an ecological paradise and center for ecotourism. And he's passionate about solving the climate crisis through some innovative ideas having to do with how we relate to water and how we use water in a very effective scientific way. So, Rob, I want to thank you for convening yet another series of sessions on climate, and turn the program over to you.
Thank you very much, Jim. Thank you very much for the amazing and persistent work that you and your team at Humanity Rising are doing. It's incredibly important what you guys are doing, and so much wisdom and novel ideas have streamed from this. So once more, thank you very much. I'm currently in Bali, and I'm actually talking to you instead of Peter Banyard, who was going to present this evening. Here it's evening at your place, it can be morning or afternoon. We did check Peter's audio system this afternoon extensively, but when we started the tests just a few minutes before, somehow it didn't work. So Peter will be on tomorrow, but I will introduce a little bit of what he was going to say, because it's relevant to what I'm going to say. So today we are presenting together with Eliza Colling and with Peter Banyard and with Peter Bruce Erie, who is still sleeping in New Zealand, the Cooling Climate Chaos Project, a practical path out of the Polycrisis. And that starts basically by understanding climate in a different way, understanding our planet in a different way, and especially starting to understand the way we should live on this planet, not in an anthropocentric way, but in a geo or Gaia-centric way. I will not steal Peter Banyard's thunder, which he has tomorrow, but what I can say is that he has been for decades a close associate to James Lovelock, and has been very well acquainted with people like Lynn Margulis, who have together created the Gaia theory, basically the paradigm that the planet is a living being and that we should understand the planet as a living being and the climate as well. So in this 3 days course, originally Peter Banyard was going to do the first one, but now I'm taking his place because of the technical problems. So I will start with the regeneration, basically the solution in in a large sense to the climate problem. Tomorrow, Peter Banyard will explain the theory behind it, which is quite wonderful and but also quite complex. And then on Friday, Eliza and Peter Bruce Erie, who is the author of How Plants Cool the Planet, will present together with some guests practical examples of how we can regenerate and improve things quickly in local places. So I'm going to share my screen now and show you a presentation. And let me see if I can get this to do that completely. Let me see where I have. Present. Where's the present button? Oh, here. Okay. Yes, this should be it. So we start with part two due to the circumstances, and basically the idea is that we can stabilize the climate and cool the planet in a relatively short period. And we do this from the perspective of the living planet, or basically the Gaia hypothesis of James Lovelock, of which basically Peter Banyard has been one of the people who has been developing it. And this will bring hope and social perspective to the situation we are in. A few words about me. My name is Rob de Laat. I'm born in 1956, Dutch. I live mostly in the Brazilian Atlantic rainforest for the last 10 years, where I've been reforesting a small valley and learned a lot, studied philosophy, traveled the world and lived on 4 continents. I have been conscious about the planetary crisis since 1974. And have been an entrepreneur in adventure and ecotourism for the last since 1996. And from 2010, I have been fully engaged, full-time and voluntary in the climate crisis and the possibilities to solve this crisis. When you look for solutions, at some point you come to the conclusion that you have to work especially at the most important points on the planet. And since April 2019, I focused entirely on saving the Amazon rainforest from dieback, because that is a planetary cooling organ that, if that would really die back, our species will not survive. So I've been working on large reforestation projects in the Amazon rainforest, and still am doing that. I'm a member of the Eco Restoration Alliance and a fellow of the Global Evergreening Alliance, all people busy with regeneration. So, and here is where part of the hope of my story starts, because I bought this valley in 2010 and started to live there 2 years later, when we had a little bit of electricity and internet, and started to reforest. And within 6 years, that area started to become a lot greener. But that was not that was the obvious thing that was happening, but actually it had an amazing impact on the local climate. And it made me optimistic, because first of all, we have seen that in the valley itself, the temperature went down by a couple of degrees by simple tree planting, leaving forests alone, and what they call water management, which is basically digging holes to slow down the water when it falls, so that it has time to infiltrate into the ground. Within this short period of time, springs came back. We planted trees around it, and springs came back and are now perennial. And in the last big drought in the region, all the places around us were without water, except in this little valley. So the microclimate reacted very fast to the simple measures that were taken. The bird life has increased enormously. I say fivefold here, but I don't know. They haven't been counted. But basically, I quite often say that it's a refugee camp for birds, because it's just incredible compared to the valleys around it. And we had, for the first time, jaguar and puma sighted in the area for the first time in living memory. So what I would like to say straight away is that biodiversity and climate resilience are strongly linked, and that regeneration is fast and easy. So, but why are things going wrong right now? I mean, we are with 8 billion people on this limited planet, and we're all seeing the consequences of what is happening with the deterioration of our environment and the climate. And as Jim said, rightfully so, more and more extreme weather leading to large disasters. Just today, the Formula One was cancelled because of large rains in northern Italy, where they have a drought. And the big rains will not help the drought because the runoff is so fast. So the current climate story is, okay, it is caused by greenhouse gases. And that's simple, but it's just a part of the story. And if we only focus on that, basically we fall into the abyss, as you can see on this cartoon. And the new climate story, which will be underpinned by Peter Banyard tomorrow, is that climate change is caused to some extent by greenhouse gases, but by a larger extent by the destruction of the biosphere. So when you see that the IPCC basically is all focusing on what to do about CO2, and more people are opening up to the fact that it's just a very small part of the climate story. The immense importance of water vapor, the immense importance of the dynamics of the oceans, of ecosystems, and of the biotic pump, for which I will tell a little bit down this presentation, as it is basically Peter Banyard is one of the three global experts on specifically the biotic pump. Now, this is a slide that is courtesy of Green Water Cools, and I saw that Marcel de Berg is watching this also. He is the one who has been designing this. As you can see that since 1880, we have had about 6.5 billion people. Our population increased by 6.5 billion people, 120 parts per million of CO2 extra. An area about the size of the United States or China has been deforested, and we have seen an increase of temperature of 1.2 degrees Celsius. Now, as you can see here in this graph, all these lines are roughly going up at the same speed, which means that what has been happening in the climate story is that the temperature rise has been mostly or solely attributed to the increase of CO2 in the atmosphere. But then correlation is not a causation, and we see that it's basically a misattribution of the reason why we're having the temperature of the planet increasing. And at the same time, I'd like to stress it one more time, our biggest problem right now is not temperature increase, it is the increase of extreme weather around the world, which gives us all these disasters and is hammering away at our societies and at food production, etc. So the new climate story says the Earth has a fever. It is caused by the damage that we have done to the biosphere through human activity. And I would like to see a little bit of what Peter Banyard would say. Basically, the climate is basically a consequence of how ecosystems, healthy ecosystems, interact with the atmosphere. All healthy ecosystems actually produce clouds and rain, and they do that through through regulating evapotranspiration and the release of small particles called cloud condensation nuclei, which are the kernels, the focus points that form raindrops. So you could say that all ecosystems, if they're healthy, whether they are in the sea or whether they are on land, actually cool the planet and also calm the weather, because they make for more rain over longer periods, but not heavy rain effects. So it's the biosphere destruction that is the real cause of climate change. And because of the incredible resilience of nature, although nature and the planet are getting really tired of the hacking away and the destruction that is happening, but we can solve the climate crisis fast if we act now and at scale by revitalizing the biosphere everywhere. We have to heal soils, vegetation, forests, hydrate land, restore water cycles and ocean lives, and redesign our destructive activities, in particular our food production and consumption. And yes, we need to get out of fossil fuels as soon as possible, but let's not forget that our food production is entirely tied to fossil fuels. For every calorie of food that we eat right now, 8 to 9 calories of fossil fuels are spent actually to produce and transport and process those and package those foods. So if you would stop fossil fuels tomorrow entirely, you would actually have a big problem with the food production. So you need to synchronize the fossil fuel problem, stepping out of the fossil fuel use with the transition of the food production worldwide. So we're going to get a little bit more technical and understand a little bit about the Earth energy balance and atmospheric hydrology to understand as a backdrop of why we are able to cool the planet and calm the weather much faster than people think. So this basically is an overall picture here given by California Academy of Sciences, which basically says, okay, there's incoming solar radiation. Some of it is reflected from the atmosphere. Most goes straight through to the surface of the air. And there it is radiated back into space via various mechanisms. One of them is evaporation and evapotranspiration, which is evaporation through plant life. And we know that when there's more greenhouse gases in this thin layer of atmosphere, which is only about 18 kilometers high or so, the re-radiated heat from the surface for a part, and I'll explain later why, will heat up the atmosphere. But what is quite often not well understood is that not all not all transport of heat from the Earth's surface to the higher atmosphere is actually heating up the planet. What does heat up the planet is so-called sensible heat. That is heat that is radiated back from hard surfaces that comes in the form of thermal radiation, which gets absorbed by greenhouse gases. However, in the case of vegetation, and especially tropical rainforests, which are the champions of recycling heat, in the case of vegetation, we see that a lot of the heat, sometimes as much as 80%, gets transported back via evapotranspiration. What is this? It's actually in the process of photosynthesis, a lot of liquid water molecules absorb energy and become gas. And this change in state of water actually makes the gas, the water vapor gas much more energy rich, and it's lighter than air, so it whirls up. but the heat that's packed in that molecule does not get absorbed by the greenhouse gases. So basically, this heat is getting transported to the higher atmosphere without any effect on the heat of the planet. And we all know that. We know that when you walk through a good, healthy forest, it's actually cool and it is pleasant. It creates its own atmosphere. So a little bit more technical, and then we get out of the more technical part, is that if you see on the top here, you see the red part and the blue part. Basically, the solar energy that is coming down on us comes in the form of ultraviolet and visible light. And if you see in the line below that, you see that where it is white, that part does not get absorbed by the atmosphere. So most of the incoming sun rays actually go straight through and are not affected by greenhouse gases at all. However, the ones that are that go back do get caught by carbon dioxide and water vapor mainly, and also, of course, by the other smaller greenhouse gases. But there's a very funny thing that at a certain level, around 10 micron, there is the so-called atmospheric window, and infrared radiation that emanates from in that wavelength actually does not get absorbed by the greenhouse gases and basically radiates straight out without having any effect on the atmosphere. And the funny part is that evapotranspiration from plants, when those gases go up, then they come to a certain level where they form clouds. At the moment that they form clouds, they are at a certain temperature that the heat radiation at the moment that the gas becomes liquid again, the thermal radiation that is then exported is actually especially in the atmospheric window. In other words, from there, a lot of that energy leaves the atmosphere. Basically, evapotranspiration through ecosystems, through especially tropical rainforest, works as a heat pump, exporting heat out of the planet. Just as a reminder, the difference between incoming and outgoing radiation is roughly 1.5%. Is only 0.5%. So if we rectify that imbalance of 0.5%, then the planet will no longer heat up. So here again, you see it in a beautiful picture, which was drawn from an article from Anastasia Makarieva, one of the experts of the biotic pump. And you see that here we also, for the first time, see the so-called biotic pump, because the trees actually evaporate this water, which then goes up and is accompanied by small cloud condensation nuclei. They then form clouds at cloud level, and at the moment of condensation, so it goes again from gas to liquid, not only does it radiate thermal radiation out into space, it also collapses to 1,000th of its volume, and that basically brings under pressure, and that sucks in moist air, and especially coastal forests basically suck in moist air from the oceans. This principle is the so-called biotic pump, which was discovered by Anastasia Makarieva and Viktor Gorshchev, and Peter Banyard has been the scientist who has actually proven the mechanism, which he'll explain to you tomorrow. So, but if we go back to forests cool in a total of 5 ways, which are by and large not in the model, only the albedo maybe. The first one is the evapotranspiration and recondensation, and at the moment of recondensation, thermal energy radiation is emitted in a part of the spectrum that's not affected by greenhouse gases, is exported into space. This is a large amount of energy. which is not well in the models. It's in the models, but it's not correctly in the models. Then, if you have more forests, they actually form more clouds. So with that, you increase the albedo of the planet and make it whiter. So the incoming radiation, a part of it already gets sent back into space at cloud level. Increased clouds means cooling the planet. And we were talking about this latent heat that is basically packed in evapotranspiration. Every joule, every unit of heat that comes down the planet and then is packed in the form of evapotranspiration is not transformed into so-called sensible heat, which you typically would get from a hard surface of a dark road, a roof, or destroyed land. So, and while that specific heat, sensible heat, would increase the temperature of the atmosphere, the latent heat doesn't. So the more you transport back in the form of latent heat, the less there is heating up. Of course, it sequesters carbon, and if we do get CO2 levels in the atmosphere down, the effect of that greenhouse gas, of course, goes down, so that's good. And the last one is this biotic pump, which basically draws in large amounts of humid air from the oceans and recycles it deep inland in various cycles of evaporation, recondensation, rain, and again, evaporation, basically irrigating the inlands of continents. Without large forests, the inlands of continents become deserts. And where you create more biomass, you also create this new increase of evapotranspiration. So it's a virtuous cycle that increases the cooling of the planet. Both Peter and I have, in different ways, made a calculation of how much forest we think we would need. And with forest, I would say biodiverse, multi-species forest, especially rainforest, because those are the champions of evapotranspiration and cooling, and agroforestry. And with that, we mean multi-layered forms of food production in the forms of food forests, as you see in the tropics, with small plants covering the ground, then bushes at maybe 2-3 meters high or 5 meters high, and then large canopy trees that take out a lot of the sun. If we would increase the size of rainforest and agroforestry in the tropical zone around the world, roughly the size of India, which is 3.3 million square kilometers, which is roughly half of the Amazon, it will be enough, according to our calculations, to stop the planet from heating up. And that's an important conclusion. So I've already talked a little bit about the biotic pump as the continent's irrigation system. And you see that where the coastal forests are removed, you see actually the reverse, and the continents are basically dried out. And you could see that that is happening in many places, that basically the planet is, the land masses are drying out because of deforestation. And if you look at the planet as a whole system, you see that these flying rivers, they go over enormous areas. The most famous one is over the Amazon rainforest, which comes in from the Atlantic Ocean on the northeast side and then recycles several times the water through rain and evaporation, until it leaves the continent all the way on in the side of Argentina. And part of that moisture actually reaches South Africa. And on the north side of the Amazon, part of that moisture goes via the Caribbean and the Pacific all the way to the United States. And you see that there's a flying river over North America, but a lot of forests have been gone there, so the power has gone down. You see other ones that if you would restore the forests over Western Europe, you would get an increase in precipitation all the way to northern China. So this system of atmospheric rivers is actually caused by the biotic pump by large forests, is incredibly important for the health of the planet. And here you see just a depiction of the seasons, and you see that large parts of the forests of the earth gets regreened during the northern hemispheric summer. Especially you see the Sahel, for instance, become green much northern during a monsoon. So it just looks that here you can see that the planet is actually looking like a living, breathing being. Here is another depiction of a similar story. Basically, this shows where at any moment in the year most biomass is created, both plant growth is there, and you see that throughout the Amazon and also the Congo and the tropical rainforest are the big 800-pound gorillas of biomass creation, while in the north, of course, it works well during the northern summer, but during the winter, nothing much happens. And here's the last picture again to understand that the planet, that what we need to do is to restore the hydrocycle through the revegetation of the continents, especially in the tropics. You see here, it's not going too well. Okay, now it's picking up, but you see that most of the moisture actually, again, is around the equator. That's where the largest impact is. But this doesn't say that we shouldn't regenerate the whole planet. We actually should. But our first priority is to get us out of the mess we're in is in tropics. Last picture on a planetary level, you can see here that about 8,000 years ago, you see a lot more forests, especially over the Eurasian Peninsula and Northern America. You see enormous forests. And for those, it's unlikely people from Australia are here because it would be in the middle of the night. But you see that the eastern coast of Australia was actually forested with thick rainforests, which actually was large enough to bring precipitation into the Australian mainland. And the cutting of those forests just since 1780 has actually led to the drying out of that continent. So coming back to the Amazon rainforest, first I would like people to realize the size of it. It really is a planetary organ. And it's quite often called the lungs of the planet, and it does produce oxygen, not 20% as quite often is said. It's probably more in the to the tune of 8%. But most importantly, it works actually as the heart of the planet because it pumps around so much humidity, sucking it in from the Atlantic Ocean, recycling it over South America, and part of that moisture all the way goes to the United States and goes to South Africa, sorry. And it has even further effects, although those are not really clear. So it's really a continent-size forest that is a planetary organ without which the total climate system would, I would say, basically collapse. A tipping point like that we cannot afford. Well, there's a couple of things more to be said around it, but I'll just leave it at that. The Amazon rainforest needs to be saved. And it's possible, especially if we work at the coastal areas near the Atlantic rainforest, to draw in much more moisture because it's drying out right now because of the destruction of the biotic pump. So here a quick overview of the red places where basically the forest has been destroyed to a large extent. And you can also see, but it would be a little bit difficult here, but you could see that the places that are most intact are defended by the indigenous people. And even today, an important chief was killed by a bullet because palm oil plantation owners wanted to have land there. And this is going on. They're actually battling for not their own land, but for the life of the planet. So here we just to summarize everything that we're doing, and again, thank you, Greenwater Cools, who has been doing a lot of this work, is that If we want to cool the planet and calm the weather, we have to look at all these aspects of the water cycle in its interplay with the atmosphere and vegetation. Vegetation is driving basically the climate. So it does reflection, it recycles rain, it buffers water in its soils and its aquifers, it creates biomass, and to transport latent heat, as we said, to the higher atmosphere, where it's then radiated out by, in a large part, through thermal radiation. It makes organic aerosols, which are the nuclei that create raindrops, and it makes clouds, which basically protect us all. There articles have been have appeared that say that reforesting the forest in the tropical zone can cool the planet by a full 1 degree centigrade for a combination of all these effects. So we're going back to Earth again, and here are some pictures from either reforestation in the northern Amazon, and you see here some Guajajara Indians who are actually doing some regeneration of land that was invaded by farmers, put grass there and then abandoned and later burnt. And you see that the temperature on that day was 42 degrees. And if you just go a little bit further, just a couple of kilometers from there, you'll find intact forests with a temperature that is considerably lower, and you can understand that there the climate is much better. So the microclimate and the macroclimate are connected. So the planetary emergency basically needs to have an other answer than the current answer, which is just about CO2. First of all, we need a complete global moratorium on logging of existing natural forests now, not in 2030. The global plan to regenerate about 1 billion hectares of degraded land and protect about 30% of the land and the ocean masses is an excellent idea, but we have to do it fast, and we really have to do it because most of these plans stay on paper. Think globally, act locally is an old adagio, but basically what it means is that the only way we can do this fast enough before we get complete collapse of our societies due to problems with our food production and water problems, the only way we can do that by letting everybody be part of an enormous movement of regeneration. And key to this all is to redesign and localize our food production, because a lot of the land that is used is basically used for food production that is now degenerative and that destroys the soils and the ecosystems. And we can diminish a lot. There's a lot more methods. There's a lot of methods now around that we can use a lot less land for a lot more food. And it will also localize, if we also localize food production a lot, it will save us a lot of transport, because we have to get the amount of fossil fuels used in food production down as fast as possible. And in the plans to reforest, we need to include the biotic pump as a crucial element, because that will increase rains over inlands. And there is, for instance, an example of the weather makers, which are already busy trying to restore the hydrology over the Sinai desert. So in the northeastern Amazon, we are slowly getting traction with this plan. And lastly, and let's not forget, and it's not part really of this series, but 2/3 of the world is ocean. The ocean ecosystems, both the coastal marine ocean systems, as well as the ocean life in the deeper seas, has been damaged a lot by pollution and overexploitation. And these are also incredibly important for restoring the climate. Now, I said that there's going to be a practical solution out of the Polycrisis, and this is basically a theoretical and a very simplified model of how we could do that. Okay, First of all, there are about 600 million rural smallholder families in the global south. And suppose you would connect them all to the internet and pay them $1 per planted tree, and then in the years after, $0.50 per tree, and then it slowly go down to 25 cents a tree. Or you would give them a microcredit to turn their open fields into agroforestry, which would increase their income considerably. In most cases, the models that we have looked at, it would increase their income by, it could double them in about as much as 5 to 7 years. So let's say that we ask these 600 million families to regenerate their own land and we pay them for it. And let's say on average, they would be able to do 1,000 trees per family. Then that's basically the thickness. If it's wood, a new forest, it roughly would be half a hectare, or what is that? A bit more than an acre. Or if it would be agroforestry, it would be maybe 4 or 5 hectares of land that they would make into agroforestry. Those 600 billion trees together would start evaporate about 30 billion tons of water per day once they're on full steam, which is about 20 years. With all the other effects that we talked about, like the increased cloud forming, the lowering of CO2 in the atmosphere, etc., basically this would be enough to stop the planet from heating up. So if tomorrow we started actually put our money where our mouth is and give money to the rural smallholder families, we would actually stop the cooling, the warming up of the planet within 20 years. At a price of $50 per ton paid for emissions for CO2 sequestration, actually the program would be paid just by the sequestration of carbon. So, and the benefits we would get is first a planet that stops heating up, a lot less extreme weather. Biodiversity would come back quickly, especially birds, bees, but later on also mammals, reptiles, etc., and also plants. The water cycles would get restored. The biotic pump would get stronger, so it would get more and more precipitation into the inlands of now drying out lands. Food and water security for billions of people would be increased and secured. And food production would become regenerative. Basically, it would build new soils, and those soils would be producing forever without the input of fertilizers and pesticides. So if we permanently increase the income of 600 million rural smallholder families in the global south by asking them to regenerate their land, and they know how to do that, and we connect them to the internet and to banking and online education, we actually we will reduce poverty at a global level, and at the same time restore hundreds of millions of hectares of soils and forests, and basically solve a large part of the climate crisis. And because the food production would be localized, and it would also no longer be a part of that cycle of machine made with chemical fertilizers, etc. A lot of the fossil fuels used right now to produce and transport and package, etc., of food would be diminished. At the same time, the rivers and the oceans would get cleaner because there's less runoff, because the water would slow down and infiltrate more into the soils. So your rivers get clearer, your lakes get clearer, and the coastal areas get clearer, which regenerates those ecosystems as well. But it needs another program, which is not part of this. We have to go zero plastic as well. This solution set does not solve the energy crisis in itself, but it does make the transition to renewables smoother. So I think with that, I will end this presentation. And I thank you for listening to my story. Again, it's a pity that Peter couldn't come up today because of the audio problems. But I hope you will listen to his story tomorrow, because his theoretical story is much more interesting and deep going than the one that I've just been telling. Thank you.
Hello, hi, I'm Eliza Collin, and I'm just going to be stepping in to do the Q&A for Rob. I'm another member of this team around cooling climate chaos. I'm a designer and researcher, specifically interested in water systems, water behaviors, agency around resource consumption and disposal, and how design can change the way we value resources such as water. I'm going to introduce myself further on Friday. So right now I'm just going to be translating your questions over to Rob. I think there's one in the chat that I can jump on now, and if anyone else has any, please start putting them in now. But Judy Hanmer asked, what is the chance of governments accepting this sort of plan, or who else might implement that plan? I think referring to the last couple slides of the presentation.
Yeah, that's a very good question. In general, we have seen that basically governments talk a lot, but their movements are far too slow. And I think that basically it's a civil society, new climate movement based on regeneration needs to take the lead. But there is one very important argument for governments in the global north to really prick up their ears and listen to this. Because if we are able to regenerate the lands in the global south in such a pace, and we bring money and we pay the people to do that, we will see less migration to the global north, which basically is the big scaremonger for countries in Europe and for the United States. And one person told me that, I think it was Ursula von der Leyen, said that the EU would pay unlimited amount of money if they found a solution to the migration problem. Well, actually we can do, because those people like to stay at home much more. They just leave their lands because they have no choice. But if we give them money and possibilities to regenerate their lands, we will see that climate migration will slow down very quickly, and hopefully even reverse, so that people can live in their beautiful lands.
Yeah, thank you. I haven't seen any other questions coming to the chat, so I'm going to jump in with one that I had. And it's actually, I mean, so we had a swap over today. Peter was meant to be presenting, and this was a question for Peter, but I think it sits quite nicely within Rob's presentation as well. How do you see this playing out on a micro and a macro scale? Because I see that there are great opportunities with narratives like this and new discoveries, such as the biotic pump, that can really change the way we as individuals relate to our environments and the agency that we feel we can have in regeneration and cooling the climate. And often the narrative is so, as Jim was saying earlier, it's so difficult for individuals to feel like they have much power within such a massive problem. So I'm interested from your experience, but also kind of dreams that you might have for the future, of how you would see the ability for agency on a micro and a macro scale with a project like this.
Well, I think, first of all, this new climate story is a hopeful story. Right now, basically, we are saying, oh, we have to stop, that things are going down. And that story of fear-mongering basically paralyzes people. And people are in denial, and because they see no solution. At the moment that they actually see that within, if we do, let's say tomorrow, we would all start to do this together, regenerating our planet where we are, but also with money where it's most important, we will see the effects within years, as I've shown in my valley that in the beginning, and people will start to be hopeful. So a new regenerative climate movement needs to basically take over worldwide. And I think the young are ready for that. They are fed up being told that, you know, their planet is going to hell and good luck with it. Actually, they should take over the leadership together with the indigenous people whose voice is getting stronger and stronger. So from the micro, everybody can do something as soon as you understand that you can decrease sensible heat from hard surfaces, and you can basically reintroduce, regenerate vegetation, especially biodiverse vegetation. Everybody has a possibility to do something at the micro level. I saw just one of the comments coming by that okay, the Miyawaki forests, small forests are very much in vogue. It's a beautiful way of actually very quickly bring biodiversity to small corners in a city, for instance. So at the micro level is for sure. At the macro level, let's say, okay, for some strange reason, tomorrow leaders prick up their ears and starting to understand what needs to be done. We could actually have a couple of crucial places that would increase, for instance, the amount of rain over the Horn of Africa because of the biotic pump. That wouldn't be in one day. You obviously have to create enormous forests, especially that starts all the way from India over Pakistan and Iran and coastal Oman. And then actually you would see that moisture would come into those areas, and that could break the drought. In fact, the Sahara was a savanna until 7,000 years ago. And that was basically probably, or at least in part, caused because of large clear cut of woods in Mesopotamia, in the Fertile Crescent, all the way to the Indus River, where the earliest civilizations, and the civilization basically is a city, which is, okay, you cut all the trees, make houses, make fortify defenses, and you need land for your agriculture. If you basically stop the biotic pump from doing its repetitive inland irrigation system. So yeah, we need to do it at the micro and at the strategic macro level.
Thank you. So there's a question that I missed, sorry for that. Shannon was asking about who's paying for the trees that the farmers would plant, again, in reference to your last few slides, I think. Maybe some clarity on that, of kind of what you're suggesting in terms of where that money would come from.
Dear Shannon, I'm so happy that you are watching this. Shannon is a dear friend of mine. Shannon, so basically right now you see that the world starts to pay to sequester carbon. And that has a certain value. So a tree growing has a certain value. So my proposal is what I call a so-called carbon credit mortgage. Because if you, for instance, I'll give you an example. If you plant new trees, biodiverse trees on a hectare of Amazon rainforest area, it will roughly sequester about 18 tons of CO2 per year for a period of about 20 to 30 years. That has a certain value. And you know that a tree, if it doesn't die from drought, or you don't cut it, or there's no fire, basically it will grow. It is very dependable. So you could basically pre-finance that value that is coming out of that CO2 sequestration and give the money up front to do the transition from open field to agroforestry. And after a few years, actually, the farmer would start making more money, not from the carbon, although he or she would also get some money from the carbon, but basically because there is much more productivity on the land and several types of food production with a higher monetary value. And these models, yeah, they're known. We know how to do that. I don't know if I explained it clearly otherwise.
Shannon, write in the chat if that was or wasn't the answer to your question. And we can move on to one from Charles, which was, how can a switch from palm oil forest to a biodiverse forest be accomplished? that's something you feel you can comment on, Rob?
Okay, well, first of all, I think we have to find a solution to the fact that we're using too much palm oil anyway, but that's beside the thing. But you see that what I know of palm oil so far is that the only way you can really do it sustainably, and in a sense that it would help the evapotranspiration, is in a biodiverse forest. So basically what you would do is sustainable harvesting of trees that were already there in the biomes where they're supposed to be. So if you add them to agroforestry systems, you don't get that many palm trees, so you don't get that much oil. So in that sense, that's a difficult one. But if you integrate it with, let's say, a total of maybe 10, 20 other species of food producing plants and trees, then the total amount of money that would be made by the local farmer is a lot more than what they get for the palm oil right now. So yes, we in the global north need to learn how to find alternatives, but palm oil can only be grown in complex biodiverse agroforestry systems with few palms.
Okay, thank you. And so we have an answer from Shannon that it wasn't quite the answer to her question. So the question is, do we pay the farmers to plant the trees, or who pays for and creates the seedlings that will be planted on those farms? Is it paid for by carbon credits, for example?
Well, basically, banks could do it. Banks could actually, give a farmer a loan. Let's say, give them a loan of $5,000 and say, okay, you promise with these $5,000 to make an agroforestry system that will sequester an X amount of CO2. The total value of CO2 sequestered over a period of 30 years, like what you do with a house, is, let's say, $15,000 or $20,000. So you don't have to pay back, as long as you actually stay with the system, do your agroforestry system, and increase your income from the produce that's coming from that forest. Then at some point, even the carbon credit mortgage, the loan that was given at the beginning, will actually start to produce extra income for the farmer because so much carbon is sequestered. So it's a simple mechanism that could finance this. But of course, you can do this in many ways. If we know, for instance, that we can increase the amount of precipitation over the Horn of Africa, where it's now drying out, I think we, as governments, could have a plan of, I don't know, a couple of tens of billions of dollars to do large-scale reforestation. Do that with locals. The locals have work and get income through this, and within a few years, you see that you'll see more precipitation, more water retention, and then you get the virtuous circle out of the drought. So there's different ways. Banks, financial institutions basically have to start regenerating the planet. And there's a very good argument, which actually comes from Marcel de Berg, who is here listening, if he's still there. Basically, it says, if you want to protect your assets, you better do something about climate change, because otherwise all your assets are going down the drain. You see now that Jim was already saying that we have soon we'll have $1 billion disaster every week, and somebody has to pay for that.
Great, thank you. So Shannon is just saying, yeah, carbon credit loans from banks could pay for trees. I think I understand. Then the forest provides new income streams. So Harriet has come in with a question, a comment saying this has been a brilliant presentation. Thank you, Harriet. On behalf of Rob. How could we get a documentary for TV done by some group like National Geographic or Planet Earth? I mean, I know this is something that you were already thinking about, Rob.
No, come with proposals. I mean, this is voluntary work. We need this plan to be actually gather stream and resources so that the plan gets promoted, because it really looks like a solution. And let me also say one warning: the way, if you look at the planet as a living being, you see that at some point living systems go past the tipping point, and then reversal is very difficult, and we're basically already sliding into accelerated degeneration of a global ecosystem. So we really have to hurry.
So another question from Charles, and I think this is one of the last, unless any more come in. And I guess this applies to more than just wood and paper, but he's saying an expanding world population requires increasing wood and paper products. How can we increase net forest growth if more wood needs to be harvested? But I guess that can also apply to many other resources.
Well, I just saw that he was talking about the incredibly important forests in British Columbia, which of course needs to stop immediately. It's complete madness that this is going on. And it was actually a remark. I'm still trying to find the source of it, but there was an Indian chief in Canada who said that the forests, the boreal forests of Canada were actually cooling Greenland. And we have to investigate that, because I think it's true. So it means actually that there's also an effect of growing forests on cooling the great ice sheets. Anyway, having said that, there are other ways. One of the most important ways that we could, for instance, do something about paper where it's necessary is producing bamboo, one of the most versatile plants in the world that grow very fast, sequester a lot of carbon, regulates the hydrocycle. And I'm not saying monocultures, but if we do that everywhere, we can use bamboo as a source.
Thank you. Okay, well, that's all the questions that I've seen. Please, anyone notify me if I've missed one. And because we had to change the program a little bit because of the technical difficulties with Peter, we're going to stop there. I wanted to invite Jim back in. Hi, Jim. If you have any questions or say any last words, and thank you very much for having us.
Thank you, Elisa, and thank you once again, Rob. So admire your passion and commitment to solve one of the most global and intractable problems confronting humanity in our generation. I just have one additional question, just because you know so much about the Amazon and you've been so deeply immersed. As everyone knows, we've had a recent election where Bolsonaro, who seemed committed to destroying the Amazon, was replaced by Lula, who promised that he would be attentive to the Amazon, and appointed Marina da Silva, who's been on Humanity Rising a couple times, as I believe was the Minister of the Environment. Would love to have your impressions, your considerations of the current state of the Amazon. I know you put up a slide showing that, you know, the southern, the south eastern part has been essentially destroyed. But what are the politics currently in the Amazon, both in terms of the Brazilian government, the Brazilian corporations, the native populations? What's the state of play?
Yeah, I understand, and thank you. Again, it's a huge area, and it's really a frontier area. Government control is not absolute there at all, and there's also a lot of money being made by mafia kind of structures, warlord kind of structures, which have a lot of power to do things through corruption, murder, and what I don't know, their whole trickery book. That said, I think that Lula, by first of all appointing a minister for indigenous peoples, has made a great move there because, of course, first of all, these are the first nations of that area, and they shouldn't get, they should get a lot of support as they have been put in a corner of that society and impoverished and everything. But those are also the ones that actually are very able to protect the forest if we empower them.
Mm-hmm.
And so that's a good move. There's a climate ministry now, and I actually know that the number 2 in the climate ministry, we had Marina Silva. I mean, I don't know if you remember, on Humanity Rising, so she is now the climate minister. And now Andre Lima, who's the second one, has actually come up with the concept of the arcs of reforestation. And one of them would be in the Northeast, acknowledging the importance of getting the biotic pump working over it. Now, I haven't seen any action yet, but at least from policy point of view, that is done. And there's a lot more policing going on. So, and which also means that actually the fighting is going on here and there in corners of the Amazon more, because, well, the forces that want to destroy and make money out of it are fighting back. But I would say that slowly we're going in the right direction. And this was the first month. Last month was the first month that there was a clear diminishing of the cut of rainforests. And Marina Silva, she was environment minister twice under Lula in the early parts of this century, and during her reign, the deforestation diminished gigantically. So good hope there.
Fantastic, fantastic. And now, are you still involved in your piece of land in Brazil?
Yes, but I still hope that someday. You said that I have a sort of an eco village or eco center there, and that's actually my vision, but I haven't gotten around it. So I'm still pretty lonely in that valley. So the invitation for people who want to come over and do something there.
Well, sometimes these struggles take a lot longer than we think.
No, but it's
so
still fun
Rob,
to be there.
listen, thank you so much for convening this 3-day panel, and thank you for your presentation today. It's so informative and empowering to think really how simple the solution is if we just simply regrow and revitalize the biodiversity of our precious planet. We would essentially solve the problem by empowering Earth systems to be vital again. So thank you for bringing this to our attention. Now, do you want to say a quick word about tomorrow and what Peter Bunyard would be covering?
Yes, please. So I'm pretty sure we get his audio fixed by that time. And so again, Peter is one of the most important theorists alive of the Gaia theory, and one of the most senior people who understands the biotic pump principle into detail. So, and he will show more into detail how the climate actually works, what energy is involved. So basically the story that I've done in an amateurish way, he will drill down to how climate really is working.
Fantastic. Well, thank you so much. And that'll do it for us for today, everyone. You're all welcome to the after session chat group. You'll see the link in the chat. And then we'll see everyone tomorrow, same time, same station, for part 2 of our 3-day program with one of the great scientific minds of our time. I'm very excited about tomorrow, Rob, because just to revisit James Lovelock and Lynn Margolis and the Gaia hypothesis, which is now a Gaia theory, is a very exciting thing for us humans to realize that we're part of a living ecosystem with intelligence, with compassion, with deep caring for each and every one of her species. So we'll see you tomorrow. Thank you, everyone. Bye for now.
Thank you.